Hi, and welcome back to another episode in the C# Practical Funkiness series. In today's episode, we're diving into two closely related functional programming concepts, currying and partial application. Before we even begin, it's helpful to have a simple mental model for the differences between the two. Currying is about the structural transformation of functions, breaking a multi-parameter function into a sequence of functions that each take a single argument. Partial application, on the other hand, is about fixing or supplying some arguments to a function up front and being returned a new function that expects only the remaining arguments. With that in mind, let's begin with currying. As mentioned, but worth emphasizing, currying transforms a function so that it becomes a chain of functions where each function in the chain accepts only a single argument. This is more than just a theoretical concept. In many functional programming languages, this is actually what happens under the hood. Even if you write a function that appears to take multiple arguments, the compiler transforms it into a series of nested single argument functions. Let's walk through this simple demo on currying to understand how it works. We start with a plain uncurried function as shown on line 19. This is a standard multiple argument function. We pass all three arguments at once and get a result. Now imagine that we wanted to supply just one of those arguments now and delay the supplying of the others until later. To do that, we can use currying. The curried version of the function on line 26 is a function that takes one argument, then returns a new function that takes the next argument, and so on. It's a chain of functions, each accepting just one value. And as a side note, when we supply a value to part of the function's argument list, that's known as partial application, because we're partially applying the function. You can, if you wish, use this function as shown on line 28. It's ugly, but it works. Now let's see how we can break it down into smaller steps. On line 35, we apply just the first argument, x equals 10. This gives us a new function that now expects the next two arguments, y and z. Again, we can execute the full chain if we provide the missing y and z argument values. On line 44, we provide the second argument, y equals 20, and get back another function that now expects the final argument, z, which when provided will return the final result. Let's run the app and view the results. All as expected. This layered approach is exactly what currying gives us. It breaks down multi-argument functions into neat, reusable pieces. And as we've just seen, each level of application produces a new function that requires fewer parameters. That's the heart of currying. I've kept this example as simple as possible because currying can be a tricky concept to wrap your head around at first. The way I think about it is a bit like stepping through a wizard. Each stage captures one argument, then moves you forward, asking for the next until the function is fully built and ready to use. Once you see it that way, the idea of chaining single argument function starts to feel a bit more natural. If you download the source code, I mention in the comments currently out of view that if you want to dive deeper into currying, you can experiment by creating a generic helper function with overloads that break a function down one argument at a time. Alright, let's move on to the next topic, partial application. Before diving into the demo code, let's look at the foundation we've built using delegates and extension methods. This approach helps to simplify things, especially when working with long function signatures. Also, keep in mind that in C# we can't attach extension methods directly to standalone methods. But by assigning those methods to delegate types, we make it possible to use extension methods. So the delegates here aren't just for clarity and expressiveness, they also enable our extension-based design. The email delegate represents the full method signature for sending an email in our domain. Keyed sender is a delegate that represents a partially applied email function where the API key, priority, and from address have already been supplied. Now let's see how we can apply partial application using extension methods. I prefer contextual extension methods that match the domain, like create keyed sender or create campaign emailer. But if you want something more generic, you can certainly create general purpose partial application extension methods with multiple overloads. Let's walk through what our extensions actually do. Our create keyed sender method captures the API key, priority, and from address, fixing them to the returned function keyed sender that now only needs the subject, body, and recipient address. Then we have create campaign emailer, which builds on top of the keyed sender by allowing the subject and body to be supplied next. The result, a highly focused function that only requires the recipient address to send an email. These kinds of layered functions are composable and expressive, and you'll design them in whatever order best matches your domain and workflow. For instance, maybe you only fix the API key at startup and apply the other parameters later. Now let's look at the demo code. On line 37, we define the real workhorse, the send email method. It just simulates sending an email by writing details to the console. In a real-world app, this would likely live in an email module or an email service. Back near the top on line 13, we simulate a list of user email addresses, maybe something you'll pull from a database. Then we assign our send email method to a variable of type email sender. This is what makes extension methods available to us. Using our create keyed sender extension, we build a function that fixes the API key, priority, and from address. This gives us a partially applied function we can reuse throughout the application. Next on line 24, we go one step further with create campaign emailer. Here we supply the subject and body and get back a new function that only needs the recipient address. Now that we have this tailored email sender, we can use link to map over our list, passing each email address to the campaign function. This gives us an array of tasks. Finally, we await those tasks with task.whenAll. In this simple example, we discard the results, but in a production app, you might log failures or retry. Let's run the example and view the output. We see our 4 emails being sent. The first one was sent using the keyed sender function, where we still needed to supply the subject, body, and recipient's address manually. The next 3 outputs were sent using the campaign emailer. Since this function already had the API key, priority, from address, subject, and body fixed, we only had to provide the recipient address, which came from our users list. Personally, I find it's not the mechanics of partial application that are tricky, but remembering when and where it really shines. Still, it's a powerful and elegant tool to have in your functional programming toolbox, especially when you want cleaner, more composable code. With that, I think it's time to wrap things up for today. As always, feel free to leave good or bad comments, and I'll do my best to answer any questions raised. If you found this episode or the source code helpful, please consider liking and subscribing to help support the channel. Anyway, thanks for watching. Until next time, bye for now.